Your university's laboratory safety program is comprised of the Chemical Hygiene Program, Biological Safety Program, and Radiation Safety Program, and other specific topics. In this program, we will cover the Biological Safety Program and how you can use this information to stay safe and healthy in a learning environment. This Biological Safety Program has been developed to provide you with guidance on the safe handling of biological materials, safety practices to minimize the risk of exposure to potentially infectious materials, and procedures for proper use, storage, transfer, and disposal of biological materials. This program is intended for use with your chemical hygiene plan. The Centers for Disease Control and the National Institutes of Health have established 4 biosafety levels consisting of recommended laboratory practices, safety equipment, and facilities for various types of infectious agents. Biosafety Level 1 precautions are appropriate for facilities that work with defined and characterized strains of viable organisms that do not cause disease in healthy adult humans, for example, Bacillus subtilis and Chlamydomonas. Level 1 precautions rely on standard microbial practices without special primary or secondary barriers. Biosafety Level 1 criteria are suitable for undergraduate and secondary education laboratories. Biosafety Level 2 precautions are appropriate for facilities that work with a broad range of indigenous moderate-risk agents known to cause human disease, such as Helicobacter pylori, Salmonella, and Toxoplasma, which is a microscopic protozoan organism that lives as a parasite in the organs of vertebrates, especially birds and mammals. Level 2 precautions are necessary when working with human blood, body fluids, or tissues where the presence of an infectious agent is unknown. The primary hazards associated with Level 2 agents are injection and ingestion. Biosafety Level 3 and Biosafety Level 4 require special facilities which use agents that have a high risk of causing life-threatening disease. These agents require partial to complete isolation. All personnel working in laboratories or facilities where biological materials are used or stored must receive biological safety training before starting work. This training must be renewed periodically and whenever procedures are changed. Biological safety training familiarizes you with common biological hazards, your university's biological safety program, and safe practices for acquisition, use, storage, and disposal of biological material. In addition to general training, you must receive training specific to the laboratory in which you work. This training must include such topics as risks associated with the hazardous substances in the laboratory, physical hazards present in the laboratory, proper use of instruments and safety equipment, and laboratory procedures and protocols. The primary principle of biological safety or biosafety is containment. The term containment refers to a series of safe methods for managing infectious agents in the laboratory. The purpose of containment is to reduce or eliminate human and environmental exposure to potentially harmful agents. Primary containment protects students, laboratory staff, and professors and the immediate laboratory environment from exposure to infectious agents. Good microbial techniques and safety equipment provide sufficient primary containment. Primary barriers include safety equipment such as biological safety cabinets, enclosed containers, and enclosed centrifuge containers. Occasionally, when it is impractical for you to work in biological safety cabinets, personal protective equipment may act as the primary barrier between personnel and infectious materials. Secondary containment protects the environment external to the laboratory from exposure to infectious materials. Good facility design and operational practices can provide work areas that are separate from public areas or easily accessed laboratory areas. The 3 key elements of biological containment are laboratory practices, safety equipment, and facility design. When you are working with infections agents or potentially infections materials, you must be aware of the hazards associated with your work. You must be trained and proficient in biosafety procedures and techniques. Ultimately, this is your responsibility. The biohazard warning label shall be used to signify the actual or potential presence of a biohazard and to identify equipment, containers, rooms, materials, experimental animals, or a combination of these which contain or are contaminated with viable hazardous agents. The standard does not specifically mandate colors to be used on biological hazard tags. OSHA recommends that fluorescent orange, orange-red, or a similar color with the lettering biological hazard in a contrasting color is recommended. Clearly mark all containers for biological materials as to their content and the word biohazard. All persons working with this material shall be informed as to the meaning of the various tags and signs used throughout the workplace and what special precautions are necessary. After working with any biohazard, you must wash your hands thoroughly. In addition, you must wash your hands after removing gloves or any other personal protective equipment known as PPE, or before eating, drinking, or applying cosmetics, or before leaving the laboratory area. You should never touch your face after working in a biohazardous laboratory or after handling biological material. As with all hazardous or potentially hazardous material, persons working with biological material must wear a lab coat, eye protection, gloves, and shoes that fully cover the feet. Now we will discuss some important aspects of safe handling procedures. First, you should always use a mechanical pipetting device. Never mouth pipette. Direct ingestion will likely occur as a result of this outdated and dangerous practice. Aerosol production should be minimized by heat sealing or using the caps on tubes during centrifugation. Remember, when bench-type centrifuges are used in a biological safety cabinet, the centrifuge operation can create air currents that may cause the escape of a biological agent from an open cabinet. You should always use secondary leak-proof containers when transporting samples, cultures, inoculated petri dishes, and other containers of biohazardous materials. The use of syringes and needles require a lot of care. Always use a needle locking or disposable needle unit. In any case, you must take care not to stick yourself. Never recap used needles or remove them from the syringe. Needles should always be disposed of in an approved sharps container. Laboratory doors are to be kept shut and access limited when experiments involving biohazardous agents are in progress. Warning signs, which include the universal biohazard symbol and the approved bioassay or biosafety level for your laboratory, must be posted on laboratory doors. You must assure that all vacuum lines have a suitable filter and/or trap for biohazardous materials. Contaminated equipment and work surfaces must be decontaminated daily and decontaminated immediately after any spill. Contaminated materials must be transported in leak-proof containers, and miscellaneous materials such as books, journals, notebooks, and personal items must be kept away from contaminated areas. Unless specifically tested, cell cultures may contain infectious agents. You must observe universal precautions and consider all unknown cultures or specimens to be infectious, and you must treat these materials as potentially hazardous. Biological safety depends on proper cleanup and removal of potentially harmful agents. Disinfection and sterilization are two ways to help ensure biological safety in the laboratory. Disinfection is the reduction of the number of pathogenic organisms by the direct application of physical or chemical agents. Sterilization is the total destruction of all living organisms. Autoclaves use high temperature, 121 degrees Celsius, and pressure, at least 15 pounds of pressure, to sterilize and inactivate biological material. The time and setting of the autoclave cycle is dependent upon the material. Follow the instruction of your supervisor for the best method. Disinfection eliminates nearly all recognized pathogenic microorganisms, but not necessarily all forms of inanimate objects. The effectiveness of a disinfection procedure is controlled significantly by the nature and number of contaminating microbes, the amount of organic matter present, the type and condition of items to be disinfected, and the temperature. Chemical disinfectants are used in the laboratory to treat a surface or an item before or after routine use, or after a spill or other contamination. Appropriate personal protective equipment must be worn when using disinfectants, and these compounds must be used in well-ventilated areas. Liquid disinfectants are frequently used for surface decontamination and, at sufficient concentration, to decontaminate liquid waste. Factors such as temperature, contact time, pH, dispersion rate, penetrability, and reactivity of the material at the application site must be considered when selecting the appropriate disinfectant. Hazardous properties of the disinfectant relative to its efficacy must also be considered. Alcohols are used often as liquid disinfectants. The most commonly used alcohols are ethanol and isopropanol, and are most effective at concentrations of 70%. The most commonly used and generally effective disinfectant is sodium hypochlorite, commonly known as household bleach. 1% sodium hypochlorite is an appropriate disinfectant for a wide range of bacterial, excluding bacterial spores, and viral agents. Sodium hypochlorite is a strong oxidizing agent and therefore can be corrosive to metal. Diluted bleach solutions can only be used on the stainless steel surfaces of biosafety cabinets if it is immediately rinsed thoroughly with deionized water. Typically, a 70% alcohol solution is sufficient to disinfect these surfaces. A biological safety cabinet is a primary barrier against biohazardous or infectious agents. A biological safety cabinet is a ventilated cabinet which uses combinations of high-efficiency particulate air, or HEPA filtration, laminar airflow, and containment. Laminar airflow is air that flows with uniform velocity in one direction along parallel flow lines. Biological safety cabinets must be inspected and certified when newly installed, after a filter or motor replacement, after being moved, or annually. Biological waste must also be managed in accordance with state, local, and federal regulations. It is industry standard to disinfect solid and liquid biosafety level 1 or non-biohazardous waste. However, if this waste contains any hazardous chemicals, such as heavy metals or organic solvents, it must be handled as hazardous waste. Similarly, if the biosafety level 1 waste contains radioactive materials, it should be handled as outlined in your Radiation Safety Manual. Biosafety Level 2 waste is biohazardous and must be treated as regulated medical waste. These wastes include discarded cultures, stocks, specimens, vaccines, and associated items likely to contain agents that are likely to be pathogenic to healthy humans, discarded etiologic agents, waste from the production of these biological materials, and antibiotics likely to have been contaminated by agents that are likely to be pathogenic to healthy humans. Waste consisting of human blood or human body fluids, or items contaminated with human blood or human body fluids, all human anatomical waste, and all wastes that are human tissues, organs, or body parts are treated as regulated medical waste. All needles, syringes with attached needles, suture needles, and scalpels, including all sharps generated through veterinary practice likely to be contaminated with agents that are pathogenic to healthy humans, are regulated medical waste. In addition, animal carcasses, body parts, bedding, and all other waste likely to have been contaminated as a result of animals being intentionally infected with agents likely to be pathogenic to healthy humans are regulated medical waste. Any contaminated soil, water, or other debris resulting from the cleanup of a spill of any regulated medical waste is regulated. In this program, we have covered major components of a biological safety plan specifically for universities. We hope that you can use this information to stay safe and healthy in your learning environment. If you have any questions, contact your safety department.